Welcome back, everyone, or thanks for joining us if you're just tuning in. Our next speaker is Ali Burgos, and she is a Knauss Coastal Resiliency Science Fellow working with the NOS National Centers for Coastal Ocean Science. In this role, she has been working on congressional outreach for coastal resiliency. And prior to this, she had studied meteorology during her undergraduate at Rutgers University, and then focused in on studying sea level rise at Old Dominion University for her master's work. And today she's going to tell us about flooding.
Yes, that's right. Thank you, Casey. So welcome everyone. Good afternoon, or maybe morning or late afternoon, whoever is tuning in online. Today I'll be talking to you about rising nuisance flooding in Norfolk, Virginia. So first, just to start off, what actually is nuisance flooding? It has several different names, such as sunny day flooding or high tide flooding, but overall it's the same thing. We have localized minor flooding that generally isn't life-threatening. It's localized to about a block radius, and so it can really just affect a small part of a city, or if you have many of these minor events, parts of a larger city. Generally, these nuisance flood events come about due to things like very high tides, which we call king tide events, storms that are coming into the area, or even offshore wind events that can push that water up into the coastal areas. Generally, you'll have a tidal inlet where maybe that higher water can overbreach a natural barrier or even a hardened structure starting to inundate the streets. And you can actually have that water come up through stormage drainage as well. So overall, though, it kind of has the same result. It can cause road closures and cause infrastructure damage over time. So here's a photo of me in a king tide event that happened in Norfolk, Virginia. I'm smiling because I love splashing in puddles, hence the name of this talk, but most people don't enjoy having this much water right outside of their driveway. Don't want to get that salt water on your car, causes corrosive damage to it. Now, this water sometimes can be pretty shallow, less than an inch or so, but sometimes it can get pretty deep. If you see the picture on the right-hand side, that's coming up pretty close to the top of my rain boots. There are some areas as we're walking around kind of tracking where all of this flooding was that if I stepped too far, it actually would have gone into my boots. So these events can get pretty deep at times. So here are some photos that I've taken in Norfolk, Virginia, throughout the 3 years that I was there. These are all nuisance flood events that were due to storm events that were offshore and combined with high tide during that time. So Norfolk, Virginia has actually seen a 325% increase in their nuisance flooding since 1960. That is a very, very large increase. And it's not just Norfolk that's seeing this issue. We also have places like New York, Boston, San Francisco, Baltimore, and even here in DC where we start to see these events. So just curious, by a raise of hands, how many people have either been hindered by nuisance flooding or have just seen it in their lives? Okay, so for everyone online, almost everyone in the room of maybe around 30 people here raised their hands. So this is becoming a very large problem and is becoming more and more of an occurrence for people in coastal areas. So question, why do we care about this minor flooding? So it pops up, it's really annoying, you have to find a new route to work. Well, the people in Norfolk care. In the Hampton Roads area, there's over 1.5 million people there, and they host the world's largest Navy base. So we have a lot of value in that area, and we're putting a lot of money into that Navy base that they need to be aware of as these events start to increase. Now, this small flooding can actually be comparable or potentially even larger in cumulative damage, property damage, compared to infrequent extreme events such as hurricanes. So over time, some areas might start to see more cost and damage due to these lower frequency events than planning for one giant event. So that's really important for coastal managers along coastal areas to understand that risk and to determine what types of mitigation and adaptation plans they need to make going into the future if they want to start investing more of their time and money into maybe these minor events that are popping up a lot more, or maybe it still makes sense for them to be putting more of that energy into mitigating those higher extreme events like hurricanes. So to start off how we understand nuisance flooding, we kind of need to back up a little bit and think about sea level rise, which, as you could imagine, as sea level rises, we'll probably start to see more of these nuisance flood events, right? So this is an image many of you might have seen. This is the global mean sea level taken from satellite altimeters. So overall, around the world, we see about an average rise of 3.2 millimeters per year. Now, unfortunately, as good as this graph is, it really doesn't help for mitigation and adaptation plans. It's pretty useless, actually. And the reason why is because you have regional or relative sea level rise, and that can be different from that global mean average up to 50 to 100% along the coastlines. So the image that you see to the left, this is showing how deviant you can have your regional sea level compared to that global mean. So we need to be able to understand what that relative or regional local sea level rise is going to be, because that's going to affect a city's nuisance flooding differently. So the only equation is this one. I promise it's not that hard. We have our relative sea level rise, and that's made up of different components. So why is sea level rise changing in an area? The first one is anthropogenic forcing causes thermal expansion, so that heat starts to expand that water a bit more. You also have melting ice. That's not uniform around the globe. So even though you have glaciers melting, it's going to affect sea level rise in areas differently. You also have natural internal climate variability. So you have things like ENSO, those are events like El Nino, La Niñas, the Pacific Decadal Oscillation, North Atlantic Oscillation. These are all natural events that happen around the world, but actually affect water levels in different areas. Then you have your high frequency events like storms and tides that does affect your water level, albeit it's on a shorter time scale. And then finally, land motion. So if you have subsidence and uplift. So here's my very crude graph of this. We have some land that's leading down to the ocean. So we can think of that top term, your thermal expansion, melting ice, that's kind of your baseline sea level. Then you have those high frequency events that go on top of that. And then if you have that land motion sink down, so even say the water stays the same, if your land is sinking, that water is going to be coming up. So the other component on top of this, though, is internal climate variability. So that can actually act to either raise or lower that sea level rise baseline. So you can have it in the green dashed line if you have like an El Nino event, for example, that could actually increase the water level in a certain region. And then that causes those tides to also increase in their water level. You can also have it do the opposite. It could decrease that baseline, and then you'd have your tides also decrease in the area. So it's an important component to look into for your regional sea level rise into an area. So some of you might recognize this photo here in DC down by the wharf. So the goal of this research that I'm talking to you about today is to determine Norfolk, Virginia's nuisance flood frequency out to 2050 from tides alone, and then also adding in internal climate variability. So that takes on so I'll be looking at two parts. And you might be asking yourself, well, why aren't you including storms into that? It's a really important component, which it is, but we want to look at just the tides and how that's going to increase our nuisance flooding in the future to kind of provide a bare minimum of what we could be looking at in the future. So the first part, quick aerial image, we have downtown Norfolk showing in the blue arrow, and then the tide gauge where we're getting our observed water level data is in that yellow dot over there, which we call Sewell's Point. So we were able to take that record of data. It actually has a pretty long data compared for tide gauges from 1927 out to 2016. And when we plot it, we can see that we have a pretty high increase in sea level rise, about 4.6 millimeters per year. So you can already see that's higher than that global mean sea level. So next we needed to think of what are our sea level rise scenarios going to be out into the future, right? Because we want to see into the future, we need to think of what those might be. So we came up with a low, medium, and high scenario, which we have here in the green, that's showing those observed data from the tide gauge already had. And then the next is following the medium scenario taken from Tibaldi's paper back in 2012 to see what exactly Norfolk might be experiencing. That's in the black line. Sorry for people here, it's getting a little cut off on the graph. And then from that, we just took for a high scenario and a low scenario, 10 centimeters on either side of that. It is an arbitrary number, however, it does fall in line with the RCP values for sea level rise in the area. Next, we actually need tidal data. So that was created out into the future. If you have questions how this was created, I would have to reference you to our co-author for that. But this was taken, or tidal data was created from 1960 out to December of 2049. And we have our low tides in blue and our high tides in pink. And the high tides were isolated to use for the following analysis. So literally, we had our sea level rise scenarios on one hand, those 3 different ones, and we have high tide data throughout time. They literally got added together to see how much that water level is going to increase in the future. So that was done for all 3 scenarios. And then how do you actually figure out when a nuisance flood event is going to happen? That is determined by the National Weather Service, so NWS, yay us. And for Norfolk, Virginia, they determined that it's about 53 centimeters above mean higher high water. So each city does have a different threshold of when they would start to see nuisance flooding. It's not the same around the country. So moving into the first results, again, we have our sea level rise scenarios plus those high tides. Squish them together, this is what you get. So we have our medium sea level rise scenario, low and high. As you can imagine, you start to see more of these blue dots, which show a tidal event. Once the blue dots go past this red line, which is our nuisance flood level, that is when you would technically see a nuisance flood event. So we can actually pull out some numbers from this. And again, these events might be relatively short since you'll have low tide coming in after to kind of bring that water level down. So the important part from that graph is that we will start to see nuisance flood events in Norfolk, Virginia from just tides, not needing any storm events, by the year 2030. That's almost 10 years away. So from the medium sea level rise scenario, we had a total of about 460 events throughout that 20-year time period. For the low, about 66 events, and the high, upwards of 1,800 events. So as I mentioned before, though, it's not only tides that are going to be affecting an area. We also have that natural climate variability that plays a role in affecting that region's sea level rise. So what we wanted to do was to figure out how we could apply that. So if anyone's familiar with, we applied what's called an empirical mode decomposition. Basically, it acts as a filter to kind of pull out that natural variability from water level data. So if we have our water level data from Norfolk, we apply the EMD process, which I'm not going to go into. It's basically a lot of MATLAB code. But to give you an idea of what this looks like is all of these squiggles. So all of these can actually be pulled out and shown into its different variability. So you're going from annual variability all the way down to multi-decadal. Shown in purple is what we took for our analysis. If you want more details on this, happy to talk offline. So that leads me into the second result of our paper. So now we're taking those sea level rise scenarios, that high tide data, and then also that climate variability, which was went through a separate analysis for us to be able to add it in for this result. So here again, we have our medium, low, and high scenario throughout time. So this one's starting from 2010 out to 2050. And this is on the y-axis, the number of flooding events. So in the black line, that is the average number of events through time that take into account your sea level rise, your tides, and that natural variability. The red dashed lines on the side, that's the 95% confidence interval on that black line. And then in blue, that's the average number of events from my analysis of just sea level rise plus tides. So kind of pulling this out into a little bit more digestible numbers. That medium scenario had upwards of 580 events, low 140, high about almost 2,000. So by including internal climate variability, that increased the number of nuisance flood events that we'd be seeing in Norfolk, Virginia. The percentages are at the bottom there. So a little bit more about those confidence intervals. So if you notice, those red dashed lines had a pretty wide range on that graph, right? So for the low scenario, for example, it had a potential to have 0 nuisance flood events in Norfolk, or upwards of 60 in 2050. And that was all within that 95% confidence interval. So this reinforces the idea that your internal climate variability is very constructive or deconstructive. So it probably wouldn't happen where they're all combining in the same way, where you're going to have the, very, very low sea level rise, but it is theoretical. It could happen. So on the flip side, the high sea level rise scenario had upwards of 450 events by 2050. So overall, it's important for coastal planners to realize that at some point, we will start to see periods of elevated sea level rise due to that internal climate variability, and will lead to Norfolk starting to experience some of those floods at the higher end of that confidence interval. So if you have any questions, there is a paper out on this that was published in GRL of last year. So a few takeaways from this work. First, nuisance flooding in Norfolk we'll start to see from just tides alone without the need of storms in the area by 2030. And then when we add in that natural variability component, potentially a few years beforehand. This is going to be seen most likely throughout the region. This work was based on another paper that was done in Boston, who has already seen a nuisance flood event from tides alone in 2011. So in Norfolk, for us, it's a bit further out in time, 2030. But it's also important to realize that internal climate variability does play a role in looking at your relative sea level rise in an area. And other high frequency events like storms are bound to play a role to increase the severity and the number of flood days that areas are going to see. So overall, the work that I presented today is kind of acting more as a baseline. What is our minimum that we could start to see for nuisance flood events from just these tides? And then also from that natural events like El Niños and things like that. Overall, it is going to be more of a common occurrence as we go through time. But the work that everyone is doing on this has been increasing a lot of knowledge for coastal managers and planners to hopefully start mitigating from these nuisance flood events. So thank you. And then, yeah, let's go.
Okay, any questions in the room? Oh, sorry.
Okay.
So maybe you said this and I didn't catch it, but which, based on the recent past number of events, actual events, which trajectory are we on, at least based on that data, low, medium, or high?
Medium. Yeah, so Norfolk, another emphasis, which I didn't think I made in the project, is like they have seen many, many nuisance flood events, but that is all due to storm-driven events. And if we start to look into that, it looks like we're following the medium scenario. So then for the nuisance flood events that I presented, you would then ideally then start adding on storm data to see how then it could increase even further.
You mentioned that coastal managers can now mitigate the effects of these floods with this information. What can they do to mitigate those effects?
I'm not a coastal planner, but there are some things that areas can do. I think one, communication is a huge part to let residents know about these flood events, how they could potentially protect their property, like don't drive your car through this because the salt water will end up corroding it. You also could have things more like natural barriers, so like marsh plants that could start to kind of soak up that water. Once you start getting all that gray infrastructure, it's much easier for it to just keep going into the streets.
Based off your methodology, how easy would it be to replicate that analysis for other towns or cities?
It's extremely easy. So especially just the tidal analysis that was taken again from another paper that was done in Boston. I think honestly the amount of work that went into that, because it's just a coding analysis, you just need to have a good data set for what you might think sea level rise is out in the future. Creating the tidal data for the future doesn't take that long. So honestly, you could replicate this for many cities in a couple of days.
So my question is basically, maybe it's more of like extending beyond this. So I'm coming from more of a climate perspective. So looking at natural variability, have you sorted out the different signals and such, like did a case like isolating ENSO or isolating the PDO, isolating NAO, so on and so on?
So that is a great question as to why, so there's a reason why we wouldn't want to do that.
Right.
And so there is research out that does separate like an El Nino event and how much that contributes to sea level rise. However, going in the future, it's going to be the culmination of all of these events, since not just one is going to happen. So we wanted to see how all of those events will pull together to increase sea level.
And I guess with that comes the follow-up, separating the trend, the anthropogenic trend from the natural one, and being able to do a true attribution study or focus, and being able to say, okay, I can attribute this to sea level rise versus a natural variability. And then by demonstrating that we can pick up the natural variability, we can add confidence that what we're showing with the sea level rise is very much there.
Yeah, so previous to this work, we looked at 20th century regional trends around the world, and we were actually able to separate anthropogenic forcing from your internal variability. So the issue going forward is that we just don't have a long enough data set, which is partly why what we did in the past by separating out those two from 1900 to 2000 could then hopefully be used for future data to separate out those two, because you need a longer data set.
Fair enough.
Yeah.
You have a question? We did have some online questions, so pull those up now. All right, so one of the first ones was, what are some mitigation options for these events?
Yeah, so like Larissa's questions, again, I'm not a coastal planner, but some of them are like adding in more green space for that floodwaters to get absorbed by it. And then it's also difficult, and I don't know the answer to this, but since a lot of storm drainage systems get overflown, so you actually have that water coming out of those drainage systems, I don't know the answer, but something would have to be done about that type of flooding in the area.
Okay. And then someone would like to know, are you working in the Silver Spring NCOAS office?
I am working in the Silver Spring NCOAS office.
All right. That was an easy one.
Yes.
And also, did you or do you plan to use machine learning and or AI models for prediction?
That's an interesting question. I mean, short answer, no, I don't plan to do that. But it is interesting for modelers to start thinking about using those techniques moving into the future and seeing if they benefit or not.
All right, so any other questions for Allie? Okay, so we have no more online questions, so that's it for today. So thank you very much.
Thank you.